There we go, example 10. So before we discover other discontinuities, we're going to talk about things that we should already know. If a function is continuous at a point, then the function value and the limit value are the same at that point. So to evaluate each of the following limits, we're just going to take 1 and plug this into this function. So we get 4 minus 7 plus 3 minus 1 plus 1 minus 5. Okay, and so I think we get what? -5. Okay, this is something that you should know, and if you don't, you got to review it right away. Okay, don't hope that I'm going to cover it. I'm not covering this extensively. You've got to know it. All right, so you have got to take cosine and be able to plug in 5/3 pi quickly and effectively and efficiently. All right, so if you were in my class, you know all students take calculus. So 5/3 is going to be over here, so it's going to be positive. You should also know your special angles. Okay, so if we have pi over 6 or 30 degrees, we have pi over 4, 45 degrees, pi over 3, 60 degrees. Okay, and the coordinates that correspond to those. So the unit circle, your best friend. Okay, the way I taught it, 3, 2, 1, 1, 2, 3. So if we look at the 1/3 reference angle and the cosine, we see it would be 1/2. So there you go. All right, now this last one, you got to also remember logs. ln e over 2, that's 1/2. Okay, so this was a little bit of review of functions that you should know. Okay, so another type of discontinuity is a vertical asymptote. Okay, that's non-removable infinite discontinuity because it's infinite on both sides. Okay, it's not removable because we can't just plug it in with one hole. Okay, so you'll see that the limit will always fail to exist at a vertical asymptote because it's going to -infinity or positive infinity, neither of which is a limit. Okay, technically you can write infinity, but infinity is not a number. Okay, it's approaching a number, it's an idea, but it's not a specific number. So if we have some function where the right-hand limit equals infinity or -infinity, or the left-hand limit equals infinity or -infinity, we know there's a non-removable infinite discontinuity, aka a vertical asymptote, at that value. All right, so here's some functions that you should know, and you should be able to figure these out without a calculator. So ln of x, let's see, we have this function here. It looks like this. H of 0, we know that's undefined. There's a vertical asymptote there. As we look from the left side of 0, it does not exist because there's nothing there. There's nothing over here. The right side of 0, so we get closer and closer to 0 from the right, and it looks like we're going to -infinity. Okay, you can write that, or technically you can even write does not exist because infinity is not a specific number. So if you look from the left-hand side and the right-hand side, we'll see that the limit does not exist. Okay, this function, you should know that this is a parent function, or the parent function is 1/x. We're just moved over to the right 3. So the graph is going to look like this. So f of 3, undefined. There's a vertical asymptote there. You can't plug in 3 or you get 1/0. That's indicative of a vertical asymptote when you have a number in the top and 0 in the bottom. So as we look, x approaches 3 from the left side, we get -infinity. X approaches 3 from the right side. Okay, that's this way. Positive infinity. The limit as x approaches -3 does not exist. Okay, this is our volcano graph. Okay, it's kind of like the last one except for they're both positive, indicated by that squared term. So it's undefined at g of -2. -2 from the left, positive infinity. -2 from the right, positive infinity. Okay, so for the limit as x approaches -2, you could write positive infinity, or you could technically write does not exist. Okay, and the last one is secant of x, and hopefully you remember what that looks like. So what I'm going to do is draw cosine of x. Here's our buddy cosine. All right, secant is the reciprocal of cosine, so it's going to look like this. And we're going to have asymptotes wherever cosine was 0. Okay, so there you go, the nice little happy faces and sad faces. All right, so at x equals 1/2, that we're looking right there, undefined. From the left side, it's going to positive infinity. From the right side, negative infinity. From both sides, does not exist. Okay, the last type of discontinuity can be a little tricky. Okay, this is called an oscillating discontinuity. This is something that I would like you to do in your WISC. All right, so you can do this in your summary part. So if you look at this on a calculator and keep zooming in about 0, try to see what's happening, okay, and write about it in your WISC. All right, so we have this new idea of a limit, and technically what we're doing is ignore what's happening right at a certain value. What's it look like is happening? It looks like it's getting closer and closer to that value, whatever that value happens to be. Okay, it doesn't matter what's really happening there. As long as we see what is it approaching, that's what a limit is. Okay, and that's what's explained in this box. Okay, when we look for a function value, we don't care what's happening around it. We don't care if it's going up here, if it's going down here. We don't care. All we're looking at is that little part. What's happening specifically at the function value. So when you put the two together, you see that this is what the graph looks like. So the limit as x approaches c would be this, but the function value would be here. All right, and example 13, this is just a nice graph, nice messy graph, and there's just a bunch of limits on here. All right, so let's just look at them. F of as x approaches -2. So if we look on either side of -2, it appears it's going this way, it's going this way. So the limit is f of x approaches -2, infinity, or technically does not exist. That's up to you. All right, then we have as x approaches 2 from the left. So if we go down here, 2 from the left side, looks like it's approaching 5. All right, the next one, f of 4. Ignore what's happening around 4 and just look at the function value. Again, we have a 5. Now, what's the limit as x approaches 4 from both sides? So get closer and closer to 4. What's it approaching? Looks like it's approaching 5. Okay, we have 11 from the right side. So go to the right side of 11. What does it look like it's approaching? It looks like it's approaching 5. And no, not all the answers are 5. All right. So then we have x approaches 5 from the left side. So go on the left side of 5. It looks like it's approaching infinity. F of 2. What is the function value at 2? It's right there, which is 4. 6 from the right. So go to the right side of 6 and get closer. Okay, it looks like the y value is 3. All right, 6 from the left side. So go to the left side of 6. Trace the graph. What's it approaching? This time it looks like it's approaching 2. Limit as x approaches 8. So go from the left side, go from the right side. Okay, both of them are approaching the same number. That happens to be 3. F of -2. Looks like there's a dot right there, so that would be 2. Limit as x approaches 0 from the left. Go on the left side of 0, approach it, and it looks like our last one is 2. So I hope that this has been helpful, a helpful introduction to limits. We're going to keep studying. We have, I think, 4 more sections. So don't worry if you're still stressed out. Just ask questions, work with each other, and talk to me. Have a great day.